Dear students, we are going to handle with a very important concept now, that is the change of variables in multiple integrals. Suppose that integral I is this integral which is in the variables x and y, and we wish to change it to new variables u and v, and x is replaced by new variables u and v. There is some function, for example x is equal to r cos theta. Now r is like u and theta is like v, and y is another function in terms of that new variables u and v. For example, in polar coordinates, you know polar coordinates that x is equal to r cos theta, y is equal to r sin theta. So it is in new coordinates r and theta. Now this integral I is going to become, u limits here, whatever order, change of order, all these things I discussed in earlier videos. So this will become a new function in terms of u and v. There will be some function in u and v, and du and dv is going to come along with extra thing, that is the Jacobian. That Jacobian is, I'll write it here, that J is nothing but determinant of dou u by dou x, dou u by dou y, dou v by dou x, and instead of this, okay, I'm sorry, you have to calculate that new variables in the denominator, okay, dou x by dou u, dou x by dou v. That y derivative partially with respect to the new variable, okay, and u here, and dou y by dou v. In present setting from Cartesian to polar, we have to calculate dou x by dou r and dou x by dou theta and dou y by dou r and dou y by dou theta, and you all know, if you simplify, you will get this is equal to r. So this Jacobian should be replaced as r, and this du dv will become dr and d theta from Cartesian to polar. So I'll directly jump here with the point that integral in x and y dx dy is now going to become integral in u and v, that is r and theta. That function will be coming in terms of r and theta, and this r into dr into d theta, this r is the Jacobian value. So dx dy is going to become dr d theta. This extra is nothing but the Jacobian. And why we need to change the order of why we need to change the variables, let us see the problem now. Evaluate integral 0 to infinity e to the power of minus x square plus y square dy dx by changing to polar coordinates. Sometimes they don't mention by changing to polar coordinates. If it is not mentioned, we need not do, but in this problem it is our requirement. Without changing to polar coordinates, it is impossible to do this problem. So if it is required, we will do it definitely. So now coming to the solution, let I is equal to integral x is equal to 0 to infinity, integral y is equal to 0 to infinity e to the power of minus of x square plus y square dy dx. Now when we want to change, we have to see first what is the region of integration. X is running from 0 to infinity, y is running from 0 to infinity. Therefore this complete first quadrant is the domain of integration or the region of integration. So if you take any point x and y, that x will be running from 0 to infinity, y will be running from 0 to infinity. But if you convert that point into r and theta, I said in basics of 2D, separately I have recorded a video, you can see that video. So this angle is theta and this length is r. So to move that point in the first quadrant, r will run from 0 to infinity, but this theta will be only up to 90 degrees. So the value of theta will run from 0 to pi by 2, that is 90 degrees. Pi by 2 radians, that is 90 degrees. So therefore our new I is now going to become, integral r is equal to 0 to infinity, integral theta equal to 0 to pi by 2 e to the power of minus, when you substitute x is equal to r cos theta and y is equal to r sin theta, the conversions required are x is equal to r cos theta, y is equal to r sin theta. Then if this is the substitution done, then dx into dy is now going to become Jacobian, that is r into dr into d theta. So e to the power of minus x square plus y square just becomes r square into r into dr into d theta. Now these two integrals, it is actually a double integral, but the limits are constants. It is not depending on each other, so you can write it into product of two single integrals. I said in earlier video, r is equal to 0 to infinity e power minus r square into r into dr, because it is only in r, and that integral only in theta, that is just theta is equal to 0 to pi by 2 d theta. So we have converted the problem to polar coordinates. Always what we will use is this particular x equal to r cos theta, y is equal to r sin theta, and dx dy is now going to become r dr d theta. These limits to be calculated as per the given integral. In the given integral, the domain or the region of integration is complete first quadrant, so the limits are like this. Now you all know how to calculate this one. Let us take r square is equal to t. Let r square is equal to t implies 2r dr is equal to dt implies r dr is equal to dt by 2. This is all to be written in some rough work. So that step is now going to become, r is going to change to t. So when r is 0, t is 0. When r is infinity, t is infinity. So it is going to become t is equal to 0 to infinity e to the power of minus t, and r dr is dt by 2. So dt by 2, this integral into integral d theta is theta, limits are from 0 to pi by 2. So that is equal to 1 by 2 outside minus e power minus t, limits are from 0 to infinity, and it is pi by 2 minus 0, that is pi by 2 minus 1 by 2 e power minus infinity minus e power 0 into pi by 2, that is now going to become minus 1 by 2 into 0 minus 1, that is minus 1 into pi by 2. Finally it's going to become pi by 4. I hope you understood. So there is a requirement that we must have to change the variables. Here we have changed the variables as x is equal to r cos theta, y is equal to r sin theta. That is nothing but we have converted to from Cartesian to polar. So this is how we can make the difficult most problem into a very simple problem. This is how we require the change of the variables I discussed in this video, that is change of variables in multiple integrals. And that to keep in mind that you should never forget to write this factor of the Jacobian. From Cartesian to polar it is just r, but if some other values are given, x is suppose given as u square plus v square and y is given as some u square minus v square, at that time the Jacobian should be calculated and that should be written. I hope you understood.